Hello students, now we will continue in our study and we will move on to the understanding of Chicago School and the evolution of the tall office building because of the work that was done in the Chicago School. What was the Chicago School? What were its contributions that led to the development of the tall office building is what we will be looking at through this presentation. Just to do a recap of what we have covered till now, let us go back to neoclassicism, which basically means the rise of classical architecture in the 18th century, or rather a revival of classical architecture in the 18th century. Neo means neo, so neoclassicism means neoclassical, and it is this revival which is evolution based on classical buildings that happened in the 18th century. And we had studied the 4 phases of it. It was rationalist, archaeological, radical and visionary, and some amazing works were done, some amazing theories were propounded during this period that some people say the foundation of modern architecture was laid in the 18th century. Moving on to the 19th century, it was characterized by the rise of the Industrial Revolution. This came to be known as the age of the Industrial Revolution, with breakneck developments in technology ushering in an industrial society. The hand production gave way to machine production, mechanized factory system came into place that led to a very major improvement in both quality and quantity of products being produced, and water and steam power, water power and steam power was behind this development. This was powering the industry, and then iron production leading on to the production of steel later on and the development of machine tools. All of this had a major impact on architecture. Many technological and architectural innovations took place in which Britain was at the forefront. But there was also an architectural problem, an architectural confusion or a predicament, and that was that though wide variety, varied types of buildings were required during this period, but there were no examples of the required building types. For example, there was no example of a railway station in the past, there was no example of many other building typologies in the past, and they had to evolve these buildings or conceive and imagine these buildings from scratch. As a result of that, they had to depend on different approaches to design these buildings. One was the return to Renaissance period. Why? Because Renaissance was a much more flexible solution that had also come out from classical architecture with the works of people like Andrea Palladio, etc. Then it was the adoption of the principles of classical architecture, not borrowing classical architecture literally, but borrowing the principles of symmetry, axiality, etc. from classical architecture. Then Gothic architecture, because Gothic structural system was very much compatible with steel or rather iron that had come up at that time. So slender iron members corresponded to the slender structural members of Gothic architecture. And then ultimately eclecticism, a collection of historical styles. For example, we see that in the St. Pancras station. And with regard to iron itself, which played a very important role now in architecture, they realized that the train sheds inside the railway station, the shed that was required could not be achieved without the use of iron and glass, glass helping in providing light in the interiors in the extreme winters of Europe. This was a very good model, but they also were not willing to expose iron on the outside because they did not know what kind of aesthetic treatment to give it. Therefore, they began by first hiding iron both inside and outside. Then they began exposing iron on the inside and hiding it on the outside like in railway stations, and then ultimately iron began to be exposed both inside and outside as the architects grew had more and more confidence in the use of iron. But this happened much later, more closer to the 20th century. And then there was a civil engineer's approach. They did not carry the baggage of the past. They gained prominence through the grand use of steel in bridges, in factories, in exhibition buildings, etc. One of the people who made a very major contribution, and I talked about it in a separate presentation, it was the impact of the Crystal Palace, which was designed by Joseph Paxton, who was a gardener. He was not even an architect, and he used to make greenhouses, which were glass houses, and he was then asked to make this massive exhibition building in iron and glass, completely exposed iron glass, and turned out that this was one of the most prominent architectural contributions of the 19th century, because it led to what then came to be the high-tech architecture of the 20th century. Then there was Art Nouveau, and it was a reaction against the eclecticism and historicism, turning back to historical styles that was in the 19th century. Art Nouveau was inspired by natural forms like plants and flowers, and the whiplash lines and use of modern materials. So we talked about biomorphic and zoomorphic forms, we talked about osteomorphic derived from bones, we talked about mechanomorphic in the last session when we talked about buildings which were derived from machines. And Art Nouveau had various titles across different countries of Europe, and it became a widespread movement. It was characterized, like I said, by whiplash lines and biomorphic and zoomorphic forms. We also saw the most radical works like that of Antoni Gaudi, and its impact was that its influence was on the forms of the modern era, and it led architects to evolve new concepts for the modern era. So, for example, the Postal Savings Bank by Otto Wagner, or the Glasgow School of Art by C.R. Mackintosh, or the Perkusdorf Sanatorium by Joseph Hoffmann. All these buildings were the pointers towards what was to come in the modern times. Now we go across the Atlantic to the United States and see what was happening during this period in America. America gave rise to a completely new movement that came to be called as the Chicago School. Now, this was what led to the creation of the modern office building, or the skyscraper. Chicago School is not so much a movement as it came to be known as the commercial style. It was not a college of architecture, it was more a school of philosophy or thought, and its subsequent impact was felt in European and other international works. In fact, it laid the foundation of the tall office building, or the modern day skyscraper, and its strongest growth was evident from 1879 to 1910, parallel to the Art Nouveau movement in Europe. These are some examples of early skyscrapers. For example, we have the Chrysler Building. Before that, we have this building by Louis Sullivan. I believe this is the Prudential Building. We have this building in Russia today, Rockefeller Center, the Reliance Building in Chicago, and the one building that was said to be the foundational building for the tall glass and steel skyscraper, and that was the Seagram Building by Mies van der Rohe. Then we have other modern skyscrapers, like we have the Shard, we have the One World Trade Center, we have the Willis Tower, and we have the Burj Khalifa, which are all examples of modern day skyscrapers as we see them today, going all the way above 800 meters, as in the case of Burj Khalifa. How did the Chicago School movement, or Chicago School style, whichever you call it, how did it actually begin? In 1785, the American Congress divided the area of United States of America into uniform grid squares. So you find this uniform grid layout in New York, you find that in Chicago. And this was adopted by many rapidly growing cities, including New York in 1811. The streets were stereotypical grid forms which were both necessary for efficiency and economy, and uniform areas were developed more rationally, could be developed more rationally and more economically than irregular shapes and varying sizes. This was the fundamental thought behind it, that if you have uniform areas, you save on, you can economize, you can build more efficiently, you can build more rationally by having uniform grid layouts. And as a result of that, and the very reason that Chicago was turning into a major commercial center at that time, there was a massive influx of population into the city. There was explosive population or demographic growth. As you can see here, that in 1870 the population was somewhere around 300,000 or 3 lakh people in Chicago, which shot up to more than 16 lakh or 1.6 million people by within 30 years time. So 1870 to 1900, tremendous growth in population, and as a result of that there was intense pressure on the land, and that forced them to look for development in the vertical direction. So Chicago School, as we go along and I talk to you more about it, is essentially a problem solving movement. There is a problem, they solve it, and then there is another problem and they solve it, and thus they keep on solving bit by bit the problem of the tall office building. This shows the evolution of Chicago city in 1900, 1920, 1970, and now closer home in 2020. This is an example of contemporary city skylines, and this slide I have added in this presentation to show you how similar are the city skylines across the globe today. Modern city skylines, whether you take Mumbai or whether you take Singapore, you take Hong Kong, you take a city in China, you take Chicago, you take even some of the cities even I am not able to recognize. This is London, and if you look at all these contemporary city skylines full of glass and steel skyscrapers, there is such a lot of similarity between them that sometimes it becomes difficult for us to identify a particular city in the globe unless there is a specific building in the city that is a symbol of the city. For example, like I can identify this is a picture of Mumbai because of this twin imperial towers designed by Hafiz contractor. I can make out that this is Chicago because of the John Hancock Center. I can make out that this is Singapore because of this building designed by Moshe Safdie. And there are other buildings, for example this building in London, that becomes the identifying building of the city. Other than that, there is a lot of uniformity about our modern cities, but that the discussion I leave for another time. The beginnings were made in a building called the E.W. Haughwout Building. Its structure was in cast iron frame, and this was the forerunner of the steel framed skyscrapers of the early 20th century. Thus, one of the major developments that happened during this time that aided in the rise of the skyscraper was the invention of the first safe passenger elevator in 1853 by Elisha Otis. It was installed in the Haughwout Building in 1857, and this is vital for the development of the tall building. Up till now, up till the invention of the passenger elevator, the building's upper floors were not really expensive, they were not worthy to be let out, people were not willing to purchase it, because who would like to climb up 5 or 6 or 7 stories to go to the topmost floor? Therefore, the lower floors were of more value, but because of the elevator the entire story completely flipped. The upper floors started becoming more expensive and more attractive for people, because as you go up, the whole you can see further away, the visuals are better, and therefore today in our modern times the topmost floors of tall buildings or skyscrapers have the penthouses and the most expensive apartments and properties in modern skyscrapers. And these are examples of how elevators have evolved from the early times to really complex examples, elevators which are residential elevators, elevators that are capsule elevators, elevators outside the Lloyd's building of London, and even elevators installed for people with physical challenges. Now, as the skyscrapers or tall buildings began to grow in Chicago with the development of the passenger elevator, one major tragedy happened. 1871, there was what was called as the Great Fire in Chicago, that destroyed more than 810 hectares of the city, 120 kilometers of roads, that is 17,500 buildings were destroyed, $222 million worth of property, about one third of the city's valuation was gone, that is about nearly $5.3 billion today. One of the prominent things they found out through this fire was the steel is weak in fire. That resulted in steel literally melting like slag in the fire, and because of that they realized that they cannot use steel in its exposed form. Steel requires vital fireproofing. That means the structural system needs to be fireproof. This was a vital concept that they understood as a result of this tragedy. For a certain period of time they returned back to the tried and tested brick masonry construction, while they understood simultaneously the need for fireproofing the steel construction. One of the buildings that came up as a result of this return back to load bearing construction was the Monadnock Building that turned out to be the tallest building built in load bearing masonry. It is a 16-storied high early skyscraper in Chicago School, completely unornamented, and the exterior is very sleekly modern in appearance because there is no ornamentation on the outside, but it was not taking advantage of the latest structural technologies. So in terms of aesthetics it is very forward looking, in terms of structural system it is backward looking. This Monadnock building, instead of steel structural supports, had brick walls bearing the entire weight of the building. As a result of that, at the ground level the walls were 6 feet thick, 72 inches thick walls were made in this building to support it. The architects Burnham and Root, who designed these buildings, they reduced the building to a very elemental statement, and the statement was they were looking for a harmonious expression to express the height of the building. And for that the original idea they came up with the idea of the papyrus column of Egypt, that this is how the building would be, the building would symbolize the papyrus column. But as they went on with the construction, gradually stripping away all the historical detail until only this massive building in brick was left with a slightly curved base. But it also had two parts to it. This earlier part, this section that was built first, is in load bearing construction. This part that was built a little later on the south side of the Monadnock building is in steel construction, and the differences are also evident because you find that two designs start varying from each other. This is brick load bearing construction with thick walls at the base, modern aesthetics and no ornamentation. On the other hand, on the south side, structural steel frame, the wall is a curtain wall, there is slightly increased height of the building, but there is ornamentation. On one side you have a building which has an older kind of structural technology but a forward looking aesthetic. On the other side you have a part of the building which has got a very modern structural system that is in steel, but the aesthetics are backward looking, there is more ornamentation and detail. So we see this is the north side of it as you see it, and this is the south side of the building. The north and the south, you can see it here. This is the north side, this is the south side, and on the south side, to add to the ornamentation, is this projection at the roof level, and there are these brackets provided. So it is ending with a capital at the top. Again, at the street level you find the difference between the two parts of the building. Inside the Monadnock building had all Art Nouveau detailing. Art Nouveau had also penetrated into America. Architects from America had studied in Europe and they had brought Art Nouveau learning with them into America. Now one by one the various preconditions to the tall building were being met. The first one being the steel framed construction. Less weight on foundations, the height of the building was no longer limited by the strength of the walls. Only curtain walls need to be provided because the iron frame or the steel frame was supporting the load of the building. There were very massive shop windows that could be provided at the street level because the walls are only curtain and you can completely remove them, only the frame should remain, and you can provide the massive glass windows, and thus lucrative rental of ground floors store space could be achieved. Now, one of the reasons why this is impactful also is because when you look at a skyscraper, it's very difficult to visualize the skyscraper. You stand very close to it or beneath it. The whole elevation of the skyscraper is not visible to you. What is visible to you is predominantly what is visible at the street level, what the building looks like at the street level, and that is why street level facades of skyscrapers became very important. The second thing that happened and that helped them was not only the city was in a gridiron pattern, but the building themselves were designed with a steel frame which was a gridiron pattern, and this resulted in economic use of land because of the city being planned like that, economic use of materials because of the building being planned in a gridiron steel frame, as you can see it here in this building. Then the development of the floating foundation. The soil of Chicago was very muddy. It was not able to bear the load of taller and taller buildings, and as a result of this they came up with the technology of a floating foundation to have sufficiently load bearing foundations for this muddy soil. And probably one of the most important was the fireproof steel construction. As you can see here, they started adding fireproofing material outside the structural members of the building, whether it was the beams and the girders, whether it was the columns, they started adding fireproofing steel material. The iron supports were encased in cement and cavity brick filled between beams. As you can see, these cavity brick filled between the beams, and then a concrete floor was provided, and on concrete floor the gas pipes were there that were also sealed in concrete, and thus the entire steel structure was completely fireproofed. So even if the fire would result in destruction of other elements of the building, the steel frame would continue to resist and stand for a longer time. As time passed, the whole technology of fireproof structural steel frame became more and more advanced, and then you see this development in the Lakeshore Drive apartments in 1951 by Mies van der Rohe, and you see how the structural I section which is carrying the load, these are encased in concrete and covered with the cladding material on the outside. This is that column, and the I sections in between, which are only acting as mullions, are not coming all the way to the ground. As you can see, they are dividing up and providing a rhythmic facade. They are not encased. These are not encased in concrete because they do not carry any load, and if they are destroyed in the fire, it does not impinge or does not lead to the fundamental destruction of the building. Then of course there was the passenger elevator, without which the tall building would not be possible. People would not be buying the floors above. It was invented, you could build it, but no one would buy it or rent it. It was invented by Elisha Otis with easy access to upper stories, and thus formerly cheap upper floors became more valuable. Sixth was standardization. Standardization of furniture and elements like construction of doors and windows, etc. It all became standardized because everything was in a grid pattern. All the floors were identical, there was a typical floor plan, all the windows were identical, the door sizes were identical. The standardization became easy. It streamlined construction, it reduced cost and reduced because of reduction in wastage of materials. They could be mass produced in factories, brought on site and assembled, and this led to cohesive and simplified building aesthetic. Even the steel members, the I section columns, the I section beams, all could be cut to size in the factory, brought on site, riveted, bolted or welded. As a result of that, the construction really speeded up, and that also brought about reduction in cost. The seventh was an aesthetic contribution, which was the Chicago window. The Chicago window was horizontally spanned, and it had one fixed glass in between and two openable parts on the side. And thus it led to the rise of the skyscraper. That means a building that is scraping the sky. Skyscraper. High-rise multi-storied buildings for offices, warehouses and apartments. This is just an intervening slide to show you how steel started impacting buildings overall. This is the Bradbury building in Los Angeles, which is not a tall building at all, it is a few storied high only, but though it has brick and sandstone conservative form on the outside, but on the inside it was radical. It was using exposed iron in the structure, exposed iron in the balconies, exposed elevators that were running through the building, the inner courtyard bringing in light from the top using exposed iron and having glass in it, and that was pulling in light into the atrium space, and freestanding hydraulic elevators were provided, and thus it was a very unique early example of complete iron architecture on the inside. Of course, it had Art Nouveau ornamentation, as you can see in the handrails, etc. And this concept of the atrium has then continued on into modern architecture with buildings like the Lloyds of London, the HSBC, or even this earlier example of a shopping mall, or even with buildings like the atriums of hotels done by John Portman Associates, etc. So we will end here with this early stage of the Chicago School. I have told you here what were the major points that were put together that led to the development of the tall building, like the structural steel frame, the passenger elevator, the fireproof construction, the use of the floating foundation, etc. And in the next presentation I will continue from here and then come to the buildings that came up in the Chicago School movement, the architects that were involved in it, and the aesthetic question that was answered through the Chicago School, resulting in the tall office building. Thank you.